What is the difference between the different types of beacons in the Doris network?
In terms of technology, we are currently deploying the 4th generation beacons in order to replace the 3rd generation, which are getting old and keep the system in good health for years. In terms of functionalities, 90% of the network beacons are standard orbitography beacons used for orbit determination that transmit only 2 frequencies and a short identity message. In addition, 4 master beacons, Toulouse, Kourou, Artebischtuk and Papet, are tied to atomic clocks and play the role of an accurate time reference. They also transmit broadcast uploads, which give information to the on-orbit receiver software, including terrestrial positions of the antennas and time links for the time beacons. A few beacons are fitted out with peculiar configurations. For instance, Terra de Lis is a time beacon but not a master beacon. Grasse is tied to an atomic clock but is just a standard orbitography beacon.
The Doris system is used to propagate time, TAI, International Atomic Time, to the user satellites. How is this done?
Well, low Earth orbit satellites are flying at a speed of more or less 7 kilometers per second. So if you want to locate them precisely, you need to handle time with an accuracy of roughly 1 microsecond. That is why time beacons are useful. Their transmission time, or time tag, is accurately known in ground time. During each satellite pass, the time beacon's signals are also precisely time-tagged by the Doris internal clock, an ultra-stable oscillator, and a simple time transfer technique gives the correspondence between the onboard clock and ground atomic time. Using this, each Doris receiver is able, for each onboard event, a time tick, to give its value in international atomic time. Doris brings TAI to the spacecraft.
Doris is used to produce a real-time orbit with a system called DIODE. Could you explain how this works?
Doris measurements are made on board inside the receiver, so it is possible to process them directly in real time using a true real-time orbit software based on a Kalman filter. This software is called DIODE for Doris Immediate Onboard Determination, and it integrates the measurement to produce an estimation of the satellite orbit. If platform information are accurate, attitude, geometry, the estimation can be precise down to a few centimeters in real time. The satellite position is available in real time for onboard use. For instance, the Attitude and Orbit Control System, AOCS, may use this information for antenna and spacecraft pointing. Other platform equipment may also take advantage of this information. For instance, the altimeter can use the altitude to optimize its written loops. Doris DIODE position estimations are also downlinked in the telemetry, making them usable as soon as the payload data are on ground. The Doris DIODE determined real-time orbit are integrated into the distribution of near real-time altimeter data. In addition, the DIODE real-time orbit and the Doris data in RINEX format for JSON3 are now distributed within 3 hours to the IGN data center to support near real-time sounding of the ionosphere. These NRT products will be available for other satellites at a later time. Thus, when you have a Doris receiver on board, you can count on a satellite precise positioning system and several types of additional real-time information.
All the Doris data is collected and passed through the control center in Toulouse, and you use this data to monitor system performance. Could you give 1 or 2 concrete examples on how to monitor system performance?
Yes, each telemetry flow of each contributing satellite is checked as soon as received in order to verify the system good health. For example, if a station is not present, it may be due to a recent electrical power failure. If its measurements are very noisy, this may indicate that an equipment has to be serviced. If its transmitting level decreases, a beacon change may be necessary. For instance, this system integrity check once happened to reveal a building up that had recently grown close to a Doris antenna. The multipath that it was creating was the cause for perturbation of measurement residuals. Correct synchronization of the time beacons is also checked in near real time, a few minutes or hours due to the telemetry downlink delay. By this means, in case of any ground event, a rapid call to the station is possible by phone, by email, allowing a rapid reaction. Also, receivers' health are automatically checked by fast telemetry processing. Software reports, diode quality index give information about the overall system integrity.